Good morning. This is density review worksheet for Tuesday the 27th. So a lot of this should all be mostly review. Some of them are very similar to what we've seen in some of the other videos, but I'll go ahead, work through a few of these. The rest of them, you can either ask me questions or you can check the other videos because some of them are very similar to what we already did in another video. All right, so this first one is pretty straightforward. We're just using that formula, density equals mass over volume. That should be a D, that's density. So we can just do direct substitution here. So our density is 0.8765, and then mass is what we are solving for, and then the volume is going to be 250 milliliters. So one step, all you got to do, multiply that 250 to the other side, and that is going to get you the answer, which is 219 grams. So 219.125 grams is the mass. All right, that one's pretty straightforward. Let's do another one. Number 2 here. There's a little bit more going on. So it says we've got coins with a diameter of 40 millimeters and 2.98 grams per cubic centimeter, and it wants to know the mass. Okay, first thing that we want to do, again, go back to the formula, density equals mass over volume. But what you need to be aware of is that it gives us this measurement in millimeters, but the density is in cubic centimeters. So whatever that density is in, you want to convert your lengths or whatever other measurements to match what the density is. So we need to convert those millimeters into centimeters. So we've got a coin, looks something like this, right? Really a pretty skinny cylinder. We've got a coin, and what you need to know is that there are 10 millimeters equals 1 centimeter. All right, these conversions should be given to you on the test. I am going to make sure that I'm going to talk to the substitute. I'm going to talk to Miss Wiggins, make sure that these conversions are up there and available for you tomorrow. Because these are conversions that either one, you should know, hopefully, but two, if you don't know them, they need to be available to you. All right, so I'm going to take care of that. And for now, let's keep going. So we've got a diameter of 40.6, right? Now here's the thing. That's the diameter. We're going to be needing to find the volume of this coin, right? Because we want something to plug in for the volume here. So we're going to be needing to use the formula. Volume equals pi times the radius squared times the height. So we want the radius. So we need to cut that in half. So we want half of the diameter. So that tells us that the radius is 20.3 millimeters. Now, there's two more things left. First of all, we need to get that in centimeters, so you're going to divide that by 10. So divide that by 10, and that's going to give you that the radius is 2.03 centimeters. Secondly, we also need the height. Okay, this is important. This is an error in the problem. Whoever created this worksheet left off the height. The height should be it should say 2 millimeters for the height. And again, that would need to be converted to centimeters. So you would divide that by 10 and get a height of 0.2 centimeters. Now, again, on the test, that won't happen. It was just a mistake. Whoever created the worksheet forgot to put the height of the coin, because we would need that to find the volume. All right, so we're going to use that radius, the 2.03, along with the height, that is 0.2 centimeters, and we're going to put that into this volume formula. So we've got volume equals pi times the radius squared, 2.03 squared, times the height, which is 0.2. All right, so let's go ahead, find the volume. And that should give you 2.59 cubic centimeters. So we can do direct substitution into this equation now. So we have our density is 2.98 the mass, which is what we're trying to find, and then the volume is 2.59. Okay, again, same thing as the last time. Multiply that 2.59 over to both sides, and that's going to give you your answer, which is the mass is 7.7, or about 7.72 grams equals the mass. But notice, again, always read the problem. It says to the nearest gram. So rounding that to the nearest gram, it's going to give us a mass of 8 grams. All right, number 3. This one's population density. So we've got a very similar formula. It's going to be population divided by area. So we got density equals population over area. And we want to find the density, okay? So that means that we know what the population is, right? Population is 12.79 million. And the area, we need to multiply, right? It's about a rectangle. We're going to assume that this is a rectangle. Whenever the shape that they give you is close to a rectangle, just treat it like a rectangle, right? Because we don't have a formula to account for all these jagged edges out here, right? So just treat it like a rectangle, length times width. So whatever that number is, 160 times 180, that's going to be the denominator. So it'll be the population divided by the area. And whatever that gives you, that's going to be your density in people per square mile. All right, number 4. Okay, for number 4, what you want to do, go ahead and check the previous video. I believe it was the video from yesterday, the video from Monday. We had problems that were very similar to this. Where we were given a circular region, right? And we're going to use that formula. We've got density equals the population over area, right? So that gives us the density, 499, equals the population over the area. Okay, so here's what we have to do. First of all, you're going to solve for A. Second, once you solve for A, whatever that number is, you're going to set it equal to the formula for the area of a circle, okay? So once you solve for A, set it equal to that formula. Remember, the formula for the area of a circle is this, pi times the radius squared. And then you're going to solve for the radius, all right? So that's your steps. So 1, we're going to solve for A right there. 2, make A equal to this formula right here, and then 3, solve for the radius. All right, that's the steps for number 4. All right, number 5. Let's see what we got to do for number 5. So it says we've got a certain density right here, and then it wants us to find the mass. Now, notice, this is in centimeters. Our measurements are in feet. So remember, like I said, whatever they give you the density in, that's what you need to convert the lengths into. So we're going to convert these feet into centimeters. All right. So first of all, we've got our formula, right? Density equals mass over volume. Let's convert the feet to centimeters. So feet to inches, you're going to multiply by 12, right? Because there's 12 inches in a foot. So 80 feet multiplied by 12, that would be 960 inches. 1.5 feet multiplied by 12, that is going to be 18 inches. And then inches to centimeters, you multiply by 2.54, right? I'll write it down here. This is a good one to have on your notes going into the test. 1 inch is 2.54 centimeters. Okay, now we'll multiply both of these by 2.54. See what that gives us. So for that length, 960 times 2.54 is 2,438.4. And that is going to be the height of the cylinder. All right, this is going to be the height. And then the 18 times 2.54, that's going to be our radius. 18 times 2.54 is 45.72 centimeters. And that is going to be our radius. Excellent. Okay, so now we've got everything we need to find the volume of this log here. All right, so we've got volume equals, remember the formula, pi times the radius squared times the height. Well, the radius is 45.72 and the height is 2,438.4. All right, so go ahead, plug that in. Don't forget to use 3.14 for pi. And so your radius times 45.72. And then square that and then multiply that by the height. All right, and that's going to give you a volume of 16,004,681.7 cubic centimeters. All right, so we've got our density. Coming back to this formula over here, we've got density is 0.676 grams per cubic centimeter. All right, and then our mass. The mass is what we are solving for. And the volume is 16,004,681.7 cubic centimeters. All right, so we're going to multiply that 16 million by 0.676. All right, that's going to give you the mass, but make sure you're aware of what that mass is. That mass is in grams, right? Because our density was in grams. Okay, so the mass, when we multiply this number by this number, here's what that's going to give you. I'll write it. I'm running out of room. We're going to write it right here. Mass equals 10,819,164.8 grams. However, that is in grams. Look at what the question asks for. It says to the nearest kilogram. All right, so there's 1,000 grams in 1 kilogram. So we actually need to divide this answer by 1,000. All right, and then round it to the nearest kilogram. All right, so divide this guy by 1,000. Okay, so your final answer is going to be mass equals 10,819 kilograms. And that is the final answer. All right, number 6, very similar, right? Notice that it gives you a density in cubic centimeters. So all of these, again, we're going to do the same thing. You're going to multiply them by 12 to get inches, and then multiply by 2.54 to get centimeters. So all of those we're going to convert to centimeters. And then for your volume, it'll be length times width times height. So you'll multiply all three of these new measurements together once you multiply by 12 and by 2.54. And then you'll set up the equation. Density equals mass over whatever you get for volume, right? Make sure you solve for volume, whatever you get for volume. Isolate the m, so multiply that volume to the other side, just like we did in number 5. And then again, the last step, right, because the density is in grams, but it wants kilograms, what you're going to have to do is you're going to have to divide it by 1,000 to get the kilograms, right? Also notice another little difference here is we've got two different equations, right? Because the first one, it gives us this density of fresh water. So we're going to have, that's going to be like part 1 of the problem, and then you're going to do it again using this other density of salt water, right? So there's going to be 2 parts to this problem. Okay. And then it wants us to find how many more, right? So you're going to subtract them. So first of all, do what I just said using one density. So I'll set up the other one. So your other part would be 0.999997 equals mass over. And then again, you would have to find that volume down here. Okay, so you're going to set up those 2 equations. Don't forget to convert those feet into centimeters first. Solve for the mass, and then find the difference between the 2. And again, don't forget to divide that difference by 1,000 because it wants kilograms. It doesn't want it in grams. And that mass that you get is going to be in grams. All right, so divide by 1,000 at the end once you're finding that difference. All right, if you have any questions, please let me know. Number 7, this last one, is another one. It's pretty straightforward. It's density equals population over area. Right, here's your population. You'll put that in for P. And then for your area, you're going just to multiply those 2. And then that'll be your area. So then population, divide by area. That's all there is to that one. Okay, If you've got any questions, you got to let me know. I know the test is tomorrow. Please reach out to me. I'm going to be available all day. So just give me a text, give me an email, and I will respond quickly.